came to analyse the results, I think probably what we were looking for is, are there particular colours, say green or red or blue, over which visually impaired people had difficulty. Now, we didn't really find that. There were differences for particular colours, but it was rather random, and the correlation wasn't uniform across all the different colours. So we looked again at the data, and when we looked at how light or dark the particular colours were in relation to their ability to tell the difference between them, there did begin to emerge a correlation. So careful analysis of the data showed that if we start to separate colours in terms of their lightness or darkness, we could be a lot more confident about predicting how many of the general population of visually impaired people would actually see the difference. Now, that was something of a breakthrough. It doesn't rule out the fact that changes in colour for some people may well be useful, but if we're applying it across the visually impaired population, then the lightness-darkness difference is important. Now, the lightness-darkness of colours is a coordinate, a function of all colour measurement systems. Typically, colours are classified as chroma, which is the actual density of the colour. Is it a bright red or not? What's the hue of the colour? Is it red or is it green? And then the lightness-darkness. So colour is a three-dimensional form. Now, normally that runs on a scale from 1 to 100, typically. So what we found was that when we started to separate colours by their lightness-darkness on the scale, we found that as the differences became greater, more and more people could see the difference. As they reduce, so less people could see. And we took typically an arbitrary value of around about 80% of the population. What would the lightness-darkness difference of colours need to be in order to make sure they could see the difference? And that came out at round about 30 points on that scale. Below that, significant numbers could tell the difference. Beyond that, we were pretty confident that 80% and above were able to see the difference. Now, because there are a variety of different colour measurement systems around, what happened was that the data was produced in a standard format and used by a variety of people. And therefore, because the colour measurement systems are different, the vertical, it's essentially a vertical scale, darkness, lightness is different. People were, with the best possible intentions, ending up with values which weren't actually directly compatible. So there was a bit of confusion there. So things have moved on a bit from that, and that developed in a way which is now recognised to be a thing called light reflectance value, which is really a neat way of saying, where does it figure on this darkness-lightness scale? Where does this particular colour figure? Now, we're able now to be able to define what light reflectance value is. Now, there are a variety, as I say, of colour measurement systems. The international one is designated by the Commission Internationale de l'Éclairage, which is an international organisation looking at lighting and colour. Because it's international, everyone knows about it. Now, that vertical scale with what's called the CIE system is 1 to 100, and that's designated as a capital Y in the colour measurement system. Now, what we've done is adopt Y as the measure of light reflectance value. Now, that applies to the CIE colour measurement systems, but because it's international, you can use those values and transpose them into virtually any other colour measurement system that you want. So it is possible now to make a direct comparison across the world in terms of light reflectance values. Another aspect to consider, perhaps, is for new buildings, although the guidance would be equally applicable to any type of buildings. But for new buildings, The minimum requirement is normally specified by the building regulations. The regulations, of course, are developed from a statutory authority, and for most designers they tend to use the approved documents which supplement the regulations, and within this area of disability it's Part M of the regulations that apply, and it's therefore the approved document of Part M which designers and others tend to use. And the issues of light reflectance value have been included within the approved document at Part M, where it asks for a 30 points difference. In other words, a good contrast between certain materials. However, that recognises that there are many different configurations, situations within buildings where contrast needs to be provided. One such is door furniture, where it has a three-dimensional effect, and there the requirement is a bit less, probably around 15 points difference. But for the major surfaces, particularly say floors, walls, and to some extent ceilings, then there would need to be a clear difference. If you're visually impaired and you're walking around, you need to know where the extent of the floor is, particularly so if you're walking up and down stairs. Now, another related project to the Project Rainbow work we've carried out, and that looked at the way people use their own homes, and the people involved are visually impaired. And stairs tend to be poorly lit, unfortunately, and it is something, it's a place in the home where they trip and fall. Now, they don't do that very often because they know the steps. But as soon as these people move into public access buildings, accessing stairs is something of a challenge. It can be greatly assisted, obviously, by the provision of handrails, which are clearly contrasted with a background, but also the nosings on the stairs. Although if they're heavily used, they're sometimes difficult to see, they are vitally important. But, as with most of the results of Project Rainbow, they don't need to be garishly contrasting. The guidance in there at 30 points difference does enable a range of colour differences to be used. So it can, and indeed in many cases already has, produce quite a pleasant design environment, which is not the impression of some sort of hazardous area, because stairs, although they're relatively dangerous for visually impaired people, aren't hazardous. So as the visually impaired person approaches the stairs, they can identify the nosing, they can identify the handrail. Most of them use the handrail to walk up the stairs. So once they've started on that path, they tend to be fairly confident.